Hey everybody, welcome to part 2A. So let's do the first page right here. Describe the difference between a compound inequality containing the word and a compound inequality containing the word or. All right, so if it's a compound inequality with and, it needs to satisfy both. So and think both. So I want you to get me a double and a chocolate shake. That means I want both. So a compound inequality with the word and is satisfied when it is true for both. So when both lines overlap. So that means when it's the or inequality, that is true wherever one of the inequalities shades the number line. So wherever the line points, that's true. So question 2. Describe how to solve the compound inequality. Negative 2x is less than 14, or 3x is less than negative 12. All right, so I'm going to give you the hint, but this is not the answer. So you have to actually go through the work and describe it. Like if you have to add 2 to both sides, then you don't say, I'm going to use the addition property and leave it like that. You have to say, okay, I'm going to add 2 to both sides because I'm using the addition property. Then I get this result. All right, so remember if it's multiplying. So we're going to use the division. The opposite of multiplication is division. So this is the big old hint for you. So if there's a multiplication problem there, you're going to use the division property of equality. All right, so if you divide or multiply, because it's same coin, different sides, by a negative number, you must flip the inequality. So be aware that one of these inequalities, you might need to do it, the other one, you don't do it. Figure out which one it is, and you'll be golden. All right, next up, it says describe the difference between the following compound inequalities. Well, first, I'm gonna draw it. So I know it's going to be a open and a closed circle. So it's going to be less than, but more than negative 4. So if it's and, I know it's connecting. I know for a fact that in reality, it's 2 inequalities going in 2 different directions. So if it's the word and, that means where do they overlap? So in this situation right here, I understand that, the solution, A, the solution is the numbers in between negative 4 and 5, not including negative 4. Because at negative 4, it's an open circle. Maybe I want to put open circle so that I remind myself later, no, it's open circle doesn't include it. All right, so we go over here. We can actually write this in compact form. It would look like this. Negative 4 is less than x, which is less than or equal to 5. Now, the other one we can't put into compact form because it is not an and compound inequality. So what we're going to have to do is we're going to have to look at it and realize, okay, it starts at 5 and goes forever that way. All right. Now, negative 4 starts there and it goes forever that way. So if it's going forever in both directions, the solution set is going to be a little bit different than A. If it goes forever in one way and the other way, the solution set is going to be what? Try to guess the answer in 5, 4, 3, 2, 1. So the solution set for B would be all real numbers. All right, great job, guys. Let's continue. Now for direction 7 through, I forgot what's the number. Let's see, 12, 7 through 12. We are going to have to figure out, match the graph with the compound inequality. All right, well, looking at this, I can do some quick drawings. It looks like what I'm going to do is I could either do one of two things. I could either quickly graph these, or I could write what these are. I could either translate the math inequality sentence into the graph, or I can translate the graph into the math sentence. So for the first one, maybe I want to just do that. So I know that x, it's going to go forever in this direction. So I know it'd be like this. And I know this one is going to go forever in the opposite direction because it involves this. This is still there. So otherwise it'd be going that way. But it is shaded. So I know that this is going to be bigger than 4. Wait 1 second, guys. It's not equal to right there. So I can take that off right there. So I know it's going to be this. If I look at B, I can see that it's going to be, the solution is just the inside. So it's pointing like this. So this one would be x is less than 4 and is less than, or is greater than -4. It's like it's the same equation, but one thing is different. One has an and the other one has an or. This would be the and, where it overlaps. This would be the or. It cuts off anywhere for B. It cuts off wherever it doesn't overlap. So it cuts it off and say, hey, we're going to pretend that these two simple inequalities do not extend. Now, A, they do extend forever. So this would be our example of, hey, this is or, this is the same one, but and. Well, let's see which one is it. X is greater than -4. Okay, that's this one. But x is not greater than 4. Okay, well, let's go on to the next one. X is greater, nope. X is greater, nope. X is greater than -4, or x is less than 4. Okay, well, that was this one. That was A. So we know this is A. Well, I need to find x is greater than -4 and less than, oh, here it is, number 12. So this is B. All right, so I have a couple more choices right here. So I understand, I can see this one. It looks like it starts here. Let's get that off. It starts here. So this one starts here and goes this way. This one starts here and continues that way. Now they include this information. So if they include something that doesn't overlap, because that middle part does not overlap, but they still shade it in, then that means it's either an and or an or. If it includes a one line, it is or. So this has to be an or. So I know that this is going to be x is more than, take that last part off. -4, but x is also more than 4. All right, well, I go over here, I see which one is more than. X is more than -4, or x is more than 4. Looks like it's C. 7 is C. All right, next one. Now, I see that now the rest of them all have it. But this is only here. So if I only see one inequality, and there was supposed to be one here going this way, most likely this way, and now I only see one, then highly likely this is an and, where this guy doesn't make this graph real until here. The solution doesn't kick in until here. So this would be x is less than negative 4, and x is less than 4. Well, I keep putting that equal sign. I'm sorry, guys. It's not equal because there's an... Why is it not equal? Can you tell me in 3, 2, 1? All right, so let's look for the and. All right, there's only 2 ands left. So x has to be less than and less than. All right, that's 8. So this would be D. All right, the last ones. Now, if it's and, now I'm going to tell you right now, this is the same equation, but one's and one's or. Now, if I look at this one, it's the same equation. If I look at these two right here, they should have been the same one. But if you look, these will never overlap. But they're marked, and they're marked. So if they are marked and they don't overlap, they're the or statement. So that's E. Now this one, why aren't we graphing it? Because it's not overlapping. And since it's not overlapping, and we're not graphing it, it has to be the and statement, the F. All right, guys, thank you, and let's get ready for part 2B.